All right, today we are going to be talking about section 5-4. This is elimination using multiplication. And this is on page 272 if you want to follow along with your textbook. The main idea is to solve systems of equations algebraically using elimination with multiplication. And algebra standard, once again, is 9.0. Elimination. So just to review, Mrs. Lee talked to you yesterday about adding and subtracting. So we are looking for additive inverses whenever we're playing the game of elimination. So let's take, for example, this problem here. This looks a little different than what you saw yesterday because in this case, you can't see the additive inverses so clearly. It's not apparent. But the question we want to ask ourselves is, can we make additive inverses? Let's take a look at what we have. If you're looking at the x values, take a look at the coefficients, 2 and 3. Would that be easy to make additive inverses? Maybe not so much. Let's take a look at the y coefficients. There is our invisible 1 in front of our y, so that's a -1. And here we have a +4. Well, I would think if only that -1 magically became a -4, then we would have additive inverses. Okay, and of course in math there is no magic, but there is multiplication. So what I can do, let's rewrite the first equation. And using our multiplication, we can multiply or scale this entire equation by a factor of 4. If I multiply 4 and distribute that 4 into the entire equation, I will have 8x minus 4y equal to 24. Okay, this will be my new equation to work with because as you see, if we line this up with our second equation, I'm going to write the second equation right underneath. Once it lines up, you will see equation number 1 scaled and equation number 2. You can see the additive inverses right there, the opposite pairs. And once we have those opposite pairs, we can follow what Mrs. Lee told us yesterday about adding equations. We can add them now. 8x plus 3x will give us a total of 11x. 4y and -4y cancel out. 24 plus a -2 will give us 22. Dividing by 11, x will be equal to 2. Of course, we're not done here. We have our x value, but we still need to plug in or replace it back into our original equation to solve for y. Okay. We can substitute into the first equation 2x minus y equals 6. Or we can choose to substitute into the second equation. It really doesn't matter which one you choose. For this equation, remember that we had solved earlier for x and we said x was 2, so let's replace or substitute back in. And we can now solve for the other variable, y. 2 times 2 will give us 4 minus y equals 6. Subtracting by 4 on both sides, -y, that cancels out, will be equal to 2. And dividing by -1, dividing by -1, y, positive y, will be equal to a -2. So we had our x values, we have our y values. Our solution then will be 2, -2. Okay? But of course, one thing we always have to remember to do is to check. Okay. To check your work, remember this solution is the solution, the intersection of both equations. So it has to satisfy both equations. When you are checking your work, you want to substitute in x and y into both equations. Let's start with equation number 1. 2x minus y equals 6. Okay, so instead of x, I'm going to put in 2. Instead of y, I'm going to have negative 2 equal to 6. Okay, so 2 times 2 is 4, minus a negative 2, that's the same as adding 2, equal to 6, and 6 is equal to 6, so that checks. And we also want to substitute into the second equation to ensure that we have the correct solution. So equation number 2 was 3x minus, or 3x plus 4y equal to negative 2. Okay, so instead of x, we're going to substitute in 2. Instead of y, we're going to substitute in a negative 2 and see if it does, in fact, equal negative 2. 6 plus 4 times negative 2 is a negative 8. And if we work that out, 6 plus negative 8 is a negative 2. It checks. It must check both equations for it to be an accurate solution. So once you have checked both solutions, you are good to go. I want to make sure you see all of this. Give me a second. I'm going to show you an example now of a different problem. Okay. You have these two equations, equation number 1 and equation number 2. Notice that in this problem, it's not so apparent which variable you can eliminate. What if you don't see additive inverses right away? Okay, in this problem, you're going to need to multiply both equations. So you're going to take a look at the coefficients once again and determine whether it would be easier to multiply the negative 2 and the 3 to create additive inverses, or would it be easier to multiply the 9 and the negative 7 to make additive inverses? And the key here, you're looking for the lowest common multiple. Okay, I'd much rather work with the negative 2 and the 3. And thinking about my lowest common multiple between negative 2 and 3, I think that's going to be 6 and negative 6. Okay, so what I'd like to do is to make this negative 2, to multiply the entire equation by a factor of 3 to make it a negative 6. And I'd like to multiply this entire equation by 2 to make it a positive 6. In that sense, we will have our additive inverses. So let's start with the very first equation. 9a minus 2b equals negative 8. We said we can multiply this entire equation by 3. So let's do that. 27a minus 6b is equal to negative 24. Don't forget to distribute that 3 across the entire equation. Okay, so this will be our new equation number 1. Okay, we're going to do the same thing for equation number 2. We once had negative 7a plus 3b equal to 12, and now we want to multiply this entire equation by a positive 2, and that will give us negative 14a plus 6b equals 24. So this is equation number 2. Okay, and I'm going to write this equation, these two equations again on a separate sheet of paper so that it's nice and neat. So we had 27a minus 6b equals negative 24. We also have negative 14a plus 6b equal to a positive 24. Lining this up, now it's really easy to spot our additive inverses. And we know that when we add these, it will cancel out the variable b. We'll be left with 27a plus a negative 14a, which would give you 13a. This cancels out, equals 0. Dividing by 13, a will be equal to 0. All right. So now that we have a, we can substitute back into the original equation to solve for b. Okay? And remember, it's always very important to go back to the original equation. Okay, don't work with the equations that you multiplied. Always go back to the original equation. So original equation number 1 was 9a minus 2b equal to negative 8. We're going to substitute in 0. That will cancel out. I'll have negative 2b equal to negative 8. Dividing by negative 2, b will be equal to 4. So now I have my a comma b, 0 comma 4 as my solution. Of course, we are not done. What are we forgetting? We must always, always, always check our work. Okay. And again, to check your work, you're going back to the original equations and you're going to substitute in these values for a and b. Okay. So on this next page, I'll have my original equation number 1. And I'm going to substitute in 0, 4. So instead of a, I'm going to have 0. Instead of b, I'm going to have 4. 9 times 0 is 0. Minus 8 equals negative 8. 0 minus 8 is indeed negative 8. And negative 8 is equal to negative 8. So it checks for equation number 1. Remember, we also have to check for equation number 2. Okay? So negative 7a plus 3b equals 12. Let's substitute in 0, substitute in 4, and see that checks out. Negative 7 times 0, that of course is 0, plus 3 times 4 is 12, and 12 is indeed equal to 12. So we know now that our solution does check for both, so we can stop there. Okay, the problems that I would like for you to do for homework tonight will be problems number 1, 4, and 7 from workbook page 67. Please show all of your work. Remember to check your answer and bring that with you tomorrow to class. Thank you.